Our scientists found that somewhere out there, where we see these distant stars and distant galaxies, there's of course a lot of planets also. Normally we don't see them because the light comes from the stars, because they're like our sun. But around those stars, we often find planets. And what our scientists also found is that on some of these planets, we call them exoplanets, you find water. And you even find organic molecules. You find the ingredients for life. And since there is evolution, chemical evolution, biological evolution, many believe that these signs show us that there will be life out there. It's just a matter of chance. So far, we haven't proven it, but the ingredients will be there. So there will be exoplanets that have everything you need to have extraterrestrial life. Now, the only issue is that we cannot go there. We only have the one planet that we live on. And it's beautiful. It has beautiful nature. We've seen it in the Amazon. This is a walnut tree, a Brazilian walnut tree. We have these ecosystems where many species rely on each other. So in order to generate life that is actually stable, because life means you can pass on life, right? You can replicate. The only issue is that, of course, these ecosystems are dramatically endangered. Many of them have been destroyed. And much of that is due to global warming, to climate change. So when we went up the Atoll Tower, this is about 150 kilometers from Manaus, it was very apparent that here we have a unique ecosystem, the Amazon, vast land covered with rainforest. But we could also see and feel and hear from the scientists that even in the Amazon, climate change has arrived very dramatically. Over the last 20 years, 14 out of those 20 years were extreme years in the sense that the level of the Amazon has been lower when it was dry and higher in the wet season than in all the years over the last century in average. So climate change has arrived at the Amazon and it's doing damage. And it's not just that the Amazon needs to protect the planet, it's also that we need to protect the Amazon and its people there. The Max Planck Society has 84 institutes. We have 26,000 employees, about 300 directors, and they come from many different countries. We are very international. Our scientists actually come from 136 countries. And we collaborate with the whole world. We collaborate with everyone who shares our values, who believes in open science, in training the next generation, in integrity. And especially strong are also our collaborations with Latin America. Can you believe it? Over the last 5 years, we had over 10,000 scientific publications published between Max Planck scientists and scientists here in Latin America. And of course, Brazil is a prime partner. 1/3 of those publications have been done with institutions here in Brazil. But we also have almost 1,000 visiting scientists coming from Latin America to the Max Planck Society. And we have all these ongoing research projects. I should say that for us, the exchange of talent is very important. So this is why we also have programs where we help people when they return to their home country. For example, the so-called partner groups, where young principal investigators, when they return to Brazil, for example, they can stay connected to the Max Planck Society and they can continue the collaboration and use the infrastructure. So this is very important to us, and we would like to strengthen our mutually rewarding partnership. And that is part of the trip, part of the purpose of this trip that we're on. Now, as I said, 10 scientific facts about climate change. Number one, and it's almost scary that one needs to say it, but you wouldn't believe how many voices are raised where people raise doubts about climate change in general. So the number one fact, climate change is real. You can measure it. You just measure the temperature, you average, and you measure the temperature at many different points, and you get a very clear curve, which tells you that by now we are more than a degree above the temperature that we had, the average temperature before 1900 in the pre-industrial age. And the last year, by the way, was with 1.55 degrees above this average from pre-industrial times, was the warmest year ever. It's almost like every year there's a new record, not quite, but almost like that. So we have hit this 1.5 degree limit last year. Second fact, some people forgot, but you may have learned it in school. The reason why we have climate change is because of the greenhouse gases. Now, then some people say, well, but there have been greenhouse gases before. Yes, that's why we are here. If we wouldn't have any greenhouse gases, it would be a pretty cold place. So why is that? It's because when the sun shines, it's absorbed by the planet. And then in terms of infrared radiation, which is the radiation that stores the heat, if you wish, that infrared radiation is emitted from the surface of the planet into the atmosphere, and most of that goes out to the universe, but some of it is retained by greenhouse gases, not by oxygen, not by nitrogen, but by CO2, by methane and others, N2O. And those gases, why can they hold some of this heat on the planet? It's because they have so-called vibrational modes. So the atoms are swinging with respect to each other. And that means that the infrared radiation that goes to the carbon dioxide and to the greenhouse gases, some of it is stored and then re-emitted and kept on the planet. And we wouldn't be here if that mechanism wouldn't exist, because it would be just extremely cold. So it's a good mechanism. However, what we see now is that the concentration of CO2 is dramatically changing, and it's increased, and that's what you see on the right here. And when you increase that, then too much of that heat is kept on the planet, and that leads to the global warming that we've seen. Right? So it's a natural mechanism, but it's now enhanced so much that it becomes dangerous. Third fact, this climate change is made by humans. It's also something you will hear, well, it could be for other reasons. Why are you sure that it's the human activity? Well, look at the curve when you look at the amount of carbon dioxide in the atmosphere. And people will say, how do you know how it was like 10,000 years back? Well, you drill a hole into the ice in the glaciers in the Antarctica or wherever, and you can take samples and you can sample from times, what was the composition of the atmosphere thousands of years back. And this led to this curve that you see here. But what you also see is that over the last years, starting in 1911, you have this total overshoot of CO2. So the levels of carbon dioxide have increased over 400 ppm. And that is the first sign why it's human activity, because, for thousands of years before, you never would hit that limit. Now, you can look over the last years from, let's say, 1750 or so onwards. What was the concentration of carbon dioxide in the atmosphere? And what was the emission by humans, right? When we started with the industrial age, burning coal, and then later also other fossil fuels, gas and oil and so forth. And what you see is that the curve of the emissions, which is in black, is following the curve of the CO2 concentration in the atmosphere. So as humans begin to put CO2 out because of burning fossil fuels, the CO2 in the atmosphere was raised. So it's not taken away. Some of it is taken away, but much of it is actually ending up in the atmosphere. Often you hear, well, maybe it's just fluctuations in the activity of the sun. The sun is so strong, right? If it fluctuates a little bit, then maybe it just heats up the Earth by 1 degree. No, it's not the case. As scientists, we could show that. So in red, you have here the temperature curve that I've shown you before, temperature going up. And in yellow, you see the fluctuations of the activity of the sun. So yes, it's true. The sun does fluctuate in its activity to some extent. Also, its magnetic pole is actually inverting every 11 years. So that the sun is a funny star. So it's fluctuating, but it even went down in activity recently when the temperature on the planet went up. So the fluctuation in the sun activity are not related. They cannot explain the rise in temperature. Fact number 4. The temperature will increase in case we stay on that path, it will increase by about 3 degrees by the end of the century. If we would go on full power with fossil fuels, we would end much higher, 4, maybe even 5 degrees. It would take much, much stronger action to get a flat curve. We would be really working very hard. So current projections are around 2.9 degrees, but it could be up to 4, depending on how we are doing as humanity, how we agree on the policies. But don't forget one thing, when somebody who thinks climate change is not so important tells you, well, 3 degrees is not a problem, it's like a hot summer, don't worry about it. It's an average temperature. And most of the planet are water, and the water heats up slowly. So when we're talking about 3 degrees, it means that some cities in India or so go up by 10, 12, 15 degrees. It means it's unbearable to live there. You need shades on the streets in order the asphalt not to be liquid. It's not, the 3 degrees doesn't sound so dramatic, right? But it's an average, don't forget that. A large region of the land will be impossible to live on because of these increases. Fact number 5, of course, when the Earth is heating, the ice is melting, and we have huge amounts of ice, especially in Antarctica. We have actually an expert here, Ricarda Winkelmann, who's a director in Jena, and she gave me that slide. And she can tell you everything about it. She's actually going to Antarctica again very soon, taking samples. So when the temperature rises, it actually rises more on the poles than at the rest of the masses of water and land. It's more on the poles. So these ice masses are melting, and when they're melting, the sea levels are rising. And current estimates, I think, is until the end of the century, maybe almost a meter of sea level that is rising. So now again, people will say, well, one meter, maybe it's a problem for the Netherlands or so, but it's not so much. Don't worry too much about it. Well, it's a lot. It really is a lot. And why is that? Why are people affected already in 2050? About 1 billion humans. Why is that? Think about the drinking water. Humans tend to live on the sea, right? That is where life began. People would have built a harbor and would do trade and so forth. So a lot of humans live on the sea. But the drinking water will get salty even when you rise by a few centimeters. It becomes a problem because more and more salt water goes into the sweetwater reservoirs. So we will be affected very soon. And by the end of the century, for sure, several billion people will be affected by the salt water. And it's estimated that around 1/3 of the human population will be affected in some way or another by the end of the century, only because of the rise of the sea level. Since Belém is coming up, we did a simulation. You can just take the geographic data and then you can say, well, simulate when the sea level rises until the end of the century, what will happen to the Belém region? And look at that. Everything that's red here will be below sea level. Can you believe it? By the end of the century. So it has a dramatic effect. And can you imagine what the cost is to preserve some of the settlements that are there. It's basically impossible because the water also will penetrate over time. Fact number 6. Climate change is already here, and the extreme weather events become more frequent. When people tell you, well, my grandfather said they also had a big flood once. Yeah, that may be true. But you can measure that the frequency of these events goes up dramatically. And we can also measure that how extreme the events are. That also is increasing. So the duration of the event, the magnitude of the wind or the water that comes down. So it's getting more extreme and more frequent. And you can even see that over the last years. This is actually data from the NASA. And this is a good way to measure it. You can actually measure the area that is affected by floods and droughts. Right? If you measure the area, then you compare and you see that a much, much larger area has been affected over the last years by extreme weather events than just 10, 20 years back. So it's a very recent thing that people can actually feel directly. If they're hit by such a storm or flood or drought, they can feel directly the effects of the climate change. Now, our researchers are trying to help in many ways. So one thing is to be better in the prediction of these extreme weather events, and machine learning is actually helping us to do so. So we have a lot of projects going on extreme weather and using artificial intelligence to predict it and to prevent, damage to people so that people can be evacuated or warned earlier. Fact number 7, climate change contributes to the loss of biodiversity. Now, of course, here again, people will tell you, well, but biodiversity is lost because we are building roads and, we are too many people on the planet. This is all true. But we begin to see a share of the loss of the biodiversity that comes from climate change. At the moment, it's estimated to be about 7%. You see it here in green. So much of the loss of biodiversity is still due to other factors, such as that, deforestation, that we exploit, the habitat of the animals and so forth. But climate change is beginning to contribute dramatically, and this will actually increase over the next years quite strongly. And here's a simulation what will happen. So it's estimated that this loss of biodiversity that is only due to climate change, the other factors, of course, are still there. It will go up to 20% for the terrestrial life. So this is the life on the land masses. And then for the marine life in the oceans and in the water, it could even be 1/3 by the end of this century when we reach the 3 degrees. So, and why is that a really big problem? It's not just terrible that we lose all these species that, were created over millions of years or have evolved over millions of years. It's also that we rely on them because life is connected. Just think about the insects and their role in fertilization. Already some of the plants need to be artificially fertilized, when we want to grow crops or so, because there's not enough insects in some parts of the world. Fact number 8, and now we come to the issue of mitigation. What should we do? What do the scientists suggest? What is the best measure? What is the fastest way? Because there's many, many things you can do, but you have to concentrate on the factors that are most effective, right? Because we don't have time. So fact number 8, we must quickly reduce the emissions, especially CO2 emissions, greenhouse gas emissions. And that is most effectively done by moving away from fossil fuels. Because fossil fuels store the carbon, and now the carbon ends up after burning in the atmosphere. And so that is the worst. And here, if you look actually at the map of the share of primary energy consumption, right? That is the total primary energy consumption over the planet. Brazil is doing extremely well. And I think that is worth saying, especially also on the COP. Brazil already in the 70s has started with ethanol production from biomass. Of course, then you also have CO2 in the atmosphere, but it's a neutral process, almost neutral, because you first use the CO2 in the photosynthesis to grow the sugar cane and so forth. Right? So Brazil is doing well. Other countries like Norway are doing well. That is, of course, hydroelectric power, with the fjords and the fjells. But many countries are doing not so well at all, and some really don't make an effort. If you look at the electricity, it's faster because it's easier to get green than the total primary energy, where you also need the chemical industry, you need to heat the buildings and so forth. But if you look at electricity, some countries are moving. Again, Brazil, of course, is one of the front runners, but even in Europe, we have made big changes and have advanced. And this is, of course, mainly wind and solar. I also often hear from people, well, you first have to invent the right technologies. No, we had them for decades. And there's enough sun, and there's enough countries where we have enough sun and where we have enough space. And then people say, well, but we cannot store it. You only get the peaks of energy, right? When the sun shines or when the wind blows. And then in the night or when you have a week without wind, then we don't have energy. That's also wrong. It's just that we need a policy to store this energy. And that's an international effort. So we now in Germany, because we have too much renewables in the middle of the day, because we have the sun and the wind, we are now sending electricity to Austria, and they are actually pumping up the water to the mountains. And then when we need the electricity, they let it down and we get electricity back. Same with Norway. There's a new cable that has been done from Germany to Norway. So the next big step in renewables is capacity for storage. Did you know that the battery prices are coming down, and by now they're below the price for the nuclear energy? So it's just not true. We just need to take the next step and provide enough battery power, provide also storage devices. There's things like, melted salt that can keep the heat for a long time, and then you can take out the heat again to produce electricity. So it's not true that we don't have the technologies. It's just that we need policies so that these companies can also sell something and put their batteries in many different places. We are actually developing the next stage of these technologies. I give you just one example, the solar batteries. Isn't that amazing? It's a material that is at the same time a solar panel and a battery. So the sun shines in the middle of the day, and that material will store the energy for a couple of hours, and then the evening is coming out. So when you come back home to cook dinner, then it comes out. You cannot buy that yet, but the material has been developed at one of our Max Planck institutes. Or we look for entirely new energies, fusion energy. But then some politicians say, well, then we don't need wind and solar, we just do the fusion energy. This will still take a lot of time to develop. Maybe 10 years to have a demonstration facility which shows that more energy comes out than we put in. And another 10 years, to have demonstration plants. So we must go for wind, solar, and storage now. And then, the next generation or their children, they will benefit from these new technologies that will hopefully then solve the energy crisis. We also have a lot of institutes that look into chemical industry, because did you remember when you go from primary energy to electrical energy, there's this big gap? It's because chemical industry needs a lot of energy that is stored in molecules. And it also, produces a lot of CO2 when you make cement, when you make steel. And that's why we need to go to green steel or to green nickel, for example. All the metals, when they're produced, they produce CO2 for the reduction purposes. And so we have chemists and material scientists who have devised new methods to make these metals, but in a much more efficient way and using hydrogen, using electricity and so forth, so don't rely on the old coal-based process. We also have scientists who work on the transformation of the whole chemical sector. Right now, what you do when you make organic chemicals, and that can be medication or whatever, perfume, or you name it, When you make these chemicals, you start with fossil fuels, you start with oil. And so one day this needs to be biomass. It needs to be, what is left over from the sugarcane or from the palm oil production. And that needs to be fed into the chemical process. But this requires entirely new methods to make the chemicals. It requires new catalysts. It requires new processes. And so we are working on that new chemistry. It will be an entirely new universe. It will take decades, I think, to transform the whole chemistry, but it's necessary. And even, our economists and our social sciences, they are trying to find solutions. And what they found is, for example, that this global carbon pricing would actually work in simulations also if a subset of countries agrees to it. So it has to be a coalition of those who are willing to do something. Because without a global carbon pricing, we will not be able to do the transformation quickly. It will come because once you have the alternative electricity, the green electricity, it will be cheaper. But you need to stimulate the transition. And that, I think, is a great tool. Fact number 9, we must protect our carbon sinks. And the huge carbon sinks are natural carbon sinks, right? For example, the forest. Here's some numbers. I think this is almost 12 gigatons. You see it here, this green arrow, where carbon can be taken from the atmosphere and then through photosynthesis, it will be there will be a sink, forest, plants that take up that carbon, right? There's also, of course, the ocean as a very big sink. You can see it here. But most of the CO2 will actually stay in the atmosphere. And, when people tell you, well, we just do carbon capture, it's a new industry. They will take out the CO2 from the cement production and we will fix it and so on. It's good that we develop that. And actually, we have several research groups doing this. But if you look at the share for now, basically, there's nothing. I think you cannot even read it. It's 0.00004 gigatons. So currently, these are pilot projects. They are not contributing anything to carbon fixation. They may one day, and we need to do everything to take the CO2 out when it's actually produced in industry. 10% of the CO2 emissions come from the cement industry, just by making concrete for buildings. So if we can get rid of those 10% at the site of the plant, that's wonderful. We should do it. But for the time being, we must protect all the carbon sinks we have, and that includes the ocean and, of course, also the land. And when you look at this simulation here from our Max Planck Institute in Jena, you can actually see how the carbon sinks are changing over the year. So you see on the top the months, January, February, March, and so forth. And you see when it's getting light, that means there's not much carbon storage, hardly any. But when it's get dark green, then it's a very good carbon sink. And what you see is that it depends, of course, on the season, right? Not all the time do you have carbon sinks, especially the woodlands, for example, in Northern America. You see it comes and goes away. And that is because of the seasons, of course. The carbon fixation only works in certain seasons. Now, but look at the Amazon when it's coming, the Earth is turning around. The Amazon is especially important because it acts as a carbon sink all year round. This is what this shows. It's now coming here. Can you see it here? It's staying green, 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 green all the time. It's because it's a carbon sink all year round. It's a little bit better and worse over time. But it's very special in that sense. And that's why also one reason why the Amazon is so important. Now we are trying to make better carbon sinks by engineering pathways. So this is now genetic engineering of plant cells where we implement synthetic pathways where we try to fix more carbon dioxide. And this is done in Marburg, in a small city in Germany, by Tobias Erb. And they have first successes. And actually the Bill and Melinda Gates Foundation, they are funding them so that they can actually make genetically engineered plants that can store much more carbon than the natural ones. I didn't know this, but the natural process for carbon storage is not optimized by evolution. It's optimized for survival in an ecosystem. It's not optimized just to store carbon, right? The plant has a lot of different things to optimize in its ecosystem, but we can probably make better carbon sinks as well. Now, the last fact, and I'm about then to finish, maybe with a more positive note, but because it's already depressing in a way. But the 10th fact is that we must take more action now because the Earth system reacts very slowly. This is the classical simulation where a large amount of carbon is, this is in the computer. You emit a large amount of CO2, about 10 times what humans have emitted to the atmosphere, and you do a simulation of the Earth system after everything we know about the ocean, how much it absorbs, and photosynthesis and everything. And then you say, okay, I will never emit any carbon anymore. And then you ask, what is now happening? How long does the Earth take to relax? And you see, it takes thousands of years. Within a couple of 100 years, you can see some drop, but it's, not much. In the ocean, after 2,000 years, it drops to less than half. But it takes thousands of years to be fully absorbed. And here's another lie from those who don't believe in climate change. It's another lie, because they will tell you, don't worry about it. The ocean sucks up the CO2. It will go down, and then it will make carbonates, and you're fine. Actually, they are right, but look at the time scale. 10,000 years. And it will be even more to absorb all of it. So much of what you will hear by the skepticism or the people who deny climate change, there's a little bit of truth, and then they distort it to make you think it's not a problem. It is a serious concern, and that's why we always emphasize the facts. Now, here comes a little bit of hope, but also a warning. We know that humanity can do it. We know that humanity can do it. And why do we know? Because we have done it for the ozone hole. One must say it's a more, less difficult problem. But remember what happened with the ozone hole. It was detected. And then in the 70s, actually another Max Planck director who also received the Nobel Prize for this work, Cramer, in Mainz in the Chemistry Institute, he found that the reason what's happening to the ozone in the atmosphere is that these chlorofluorocarbons that were in all of our fridges, that they go up and they form radicals by the UV radiation. And these radicals would destroy the oxygen molecule. Because it's O3 and you can take out an O radical and then you have just oxygen and you destroy the ozone. And so in order to protect the ozone layer, you have to get rid of these fluorohydrocarbons. And so what people have done, they agreed to the Montreal Protocol in 1987. And then the, ozone layer recovered, and it's still recovering. And it will take, according to United Nations, it will take until 2065, 2070 to recover. So what does this tell us? It tells us, and that's the good news. Humans are, first of all, we are able to destroy the planet. We know that ever since Hiroshima, right? It's no problem for us to destroy the planet. But we are also able to detect problems. We have the scientists who can say, I know it's the fridges that destroy the ozone. And from that understanding, we can design policies. We can say no more of these chemicals, right? All of our fridges on the whole planet need to be changed. We can do that. It takes a couple of years, Montreal Protocol, and then some time frame for the industry to transform. But then it still takes 100 years to recover, right? 100 years for the whole process. So the bad news is that the response, has to be fast. And even if it's very fast, you saw, how fast we were from the 70s to the 80s. Within 10 years, humanity solved the problem, if you wish. But it takes 100 years for the planet to recover. Much worse for climate change. It's the job that we have to do this century, but people will suffer for many centuries, even maybe thousands of years for full recovery. And so that is why it's so important to be at the COP, to say that here's the scientific facts, and to also tell the politicians the scientists cannot replace the political process. They can only provide the evidence and possible solutions. You can make green steel, you can make batteries that store that, but the political process needs to be done in order to implement these changes that the scientists propose. And that's why it's so important that you all speak out and that Brazil actually leads by example. So here's the 10 facts. Once again, also, and I'm sure that you all know it, but it's very important just to let it sink in. Climate change is real, cannot be denied. It's driven by the greenhouse gases. And yes, it's a natural process that now overshoots. It's not by the sun, it's human-made. The temperature increases by 3 degrees, even with the current policy by the end of the century. By the way, 1/4 of the century is already over. Time passes very, very quickly. Our children, half of our children will actually see that year. Then sea levels are rising. This will affect people. And even if it's, half a meter, even 20, 30 centimeters, it will change the water reservoirs. It will change a lot of things. It will change agriculture. Extreme weather events are not only becoming more frequent, but also more extreme. And that actually causes a lot of cost. So when people tell you, well, this battery is expensive, how expensive, talk to the people who do insurances, how expensive it is to repair after an extreme weather event. Climate change contributes to the loss of biodiversity. It's already at 7%. It may go up to 20, 30% by the end of the century. Very dramatic. What can we do? Well, the most important factor, reduce the emissions from burning fossil fuels. Go to, both the traffic, but also the heating, but also the chemical sector. All of that needs to be changed. We need to move away from fossil fuels. And protect the carbon sinks that we have, because right now they take out a lot of the carbon from the atmosphere. Also, most actually still stays on, and that is the concern. And we must take more action now, because the reaction is very, very slow. It takes hundreds of years to normalize the CO2, and it may take thousands of years to completely go back to pre-industrial, a pre-industrial atmosphere. Yeah, so thank you for hosting the COP. Thank you all for making an effort to implement as many policies as possible, to find individual solutions for the countries, but also to propose things that those who are willing will do together now. If we wait for all countries, there will be no changes anytime soon, but those who are willing will be a majority, I'm sure. And finally, today it's the last day of our trip through Latin America. We went to Argentina, to the Amazon, Sao Paulo, Brasília. I want to thank my delegation. I mentioned Ricarda Winkelmann, but other directors have been here. Thomas Duwe from Frankfurt, Susan Trumpau from Jena, and then Victor also, he's also at the Jena Institute. And I would like to thank Caro, Sebastian, Christiane, and Tobias for organizing the whole trip. This is, several months of work that they, at least Tobias and the team, have put in, and are very grateful for that. And finally, thank you for listening, and thank you for being here, and thanks for your actions. Thanks for the attention. Thank you very much.